All right, thanks for joining me from chapter 8.6, System of Nonlinear Inequalities. So this is the same as linear inequalities, except instead of using just lines, we're going to use nonlinear equations, such as parabolas, cubics, the same stuff we used in 8.5. So the first thing you're going to want to do is graph the equations of whatever you're dealing with, of whatever that nonlinear curve is. Then you're going to shade the correct side or sides, or the inside, the outside, above or below the graph. And then you're going to highlight the solution set or sets that work. Okay. So we just kind of want to recall here that remember that when I have a less than or greater than, we're using a dotted line or a dotted curve. With less than equal to or greater than equal to, we use a solid curve or a solid line. Okay, so we're going to use the concepts from, some of the concepts from 8.5 in this 8.6, along with these inequality properties. Okay, so let's just try an inequality here. So we need to know the parent function. So I've got addition here with two squares, and I've got this 1 or this number over here. Notice there's no numbers on the left side, so this tells me that we have a circle. Because there's no parentheses in with the square, that tells me that it's centered at 0, 0. And with the circle, the radius is the square root of this number over here. So in this case, the radius is 1. Okay, so I'm going to change this graph a little bit. Instead of going by ones, we're going to go by a fifth. So let's say 1, 2, 3, 4, 5. So this is your new one. 1, 2, 3, 4, 5. There's your new one. There's a new one. And there. This kind of zooms in my graph here. So notice we have a greater than, so that means I have a dotted line connecting these radius. Okay, so there's my circle. Now we need to figure out, do I shade the inside of the circle or the outside of the circle? Well, if we look at this, this part right here represents all your ordered pairs. Okay, all these ordered pairs on this circle, or any out here. So we want my ordered pairs, you want your ordered pairs to be greater than, what does this represent? This represents your radius. So if I want my ordered pairs greater than my radius, that tells me that they have to be somewhere out here. Okay, it's saying that the distance from this circle to wherever my ordered pair is out here has to be greater than 1. And this circle here represents 1. So we want it somewhere out here. Now, if you have a hard time figuring out, well, do I do the inside? Do I do the outside? Do I do above or below? You can always test a point. Okay, so let's say we take this point right here. Let's just take 0, 0. Does 0, 0 work? Well, 0 squared plus 0 squared, is that greater than 1? Well, 0 squared is 0 plus 0 squared is 0. So that's 0 greater than 1? No. Okay, so in that case, this cannot be true, so then we shade on the outside. Okay, so if you can't just look at the equation and tell, always pick a point or two and see what happens. Graph the inequality y less than equal to negative x squared plus 3. Okay, the parent function here is a parabola because of the x squared. Now, what happens to this x squared or this parent function? Well, it gets flipped over the x-axis and moves up 3 spots. So my vertex is 3, 0. Okay, so, sorry, 0, 3. Add it backwards. So 0, 3. So there's my vertex. Okay, and it's flipped upside down from this negative. So instead of going this way, I go this way. So we'll graph a few other points. I know that there's a point, there's a point. I will go to this direction and for this direction. Now, how do I get those? Well, I know that the parent function starts at 0, 0, 1, 1, and 2, 4. 1, 1, and 2, 4. So if I start right here, I can go 1, 1, 1, 1, 2, 4, 2, 4. And that will give me this basic shape. And that's enough points to get a good idea of what's going on. Now, if I put a number here, if I stretch or shrink that, then I can no longer do the parent function. I'd have to multiply these numbers by that constant. Okay, so it is a solid line because of the less than equal to. Okay, then we're going to ask ourselves, y is less than equal to my parabola. Okay, this is your parabola. So where is the y? Now remember, your y values are right here on this y-axis. Where are those y values less than my parabola? Well, if this is my parabola on that y line, then if I go up, those numbers get bigger. If I go down, these numbers are less. So we're going to shade in under or below your parabola. Okay? Again, if you don't know, can we test 0, 0? Sure. So I've got 0 less than equal to negative 0 squared plus 3. Well, this becomes 0. So 0 less than equal to 3. Yes, that is true. So I need to shade in that portion of my graph. Okay? So now we'll move on to systems of nonlinear inequalities. So let's start with the easy one, this down here. That's a line. Now you might be asking, I thought we were dealing with nonlinear. Remember that the definition of a nonlinear system is that at least one of those equations in there is not a line. Okay, so I've got a line, but in here I've got a parabola. So this is a line, and the way we graph a line is we use the slope, which is 1 over 1, and the y-intercept, which is 1. So you go to 1 on the y-axis, and notice there's no equals, so this is a dotted line or open circles. And then I take my slope up 1 and right 1, or down 1 and left 1. And we can continue this all the way across your graph. Or you can just go ahead and draw your dotted line in there. Okay. Now, y is less than my line. So again, we're going to shade below the line we just drew. Okay. So there's the solutions for this line. Now up here we have a parabola. Okay. X squared, what happened to that parabola? It got shifted down 1. So my new vertex is 0 minus 1. Okay. It didn't stretch or shrink or anything. And it is a solid line and solid dots. So we're at 0 minus 1, then up 1, right 1, and over here, and then right 2, up 4. And then it's a mirror image over there. So then there's my parabola. Okay, so y is greater than my parabola. So that would be the inside here, or above your parabola. Now we need the solution set. Well, the solution set is going to be where your shading overlaps, and it's kind of hard because I didn't fully fill in everywhere. Okay, but if I'm shading below the line but above the parabola, where they overlap is right here. Okay. Now remember, we've got this dotted line right here. Okay, so I could not pick this point right here because it is on this dotted line. Okay. However, I could pick my vertex at 0, negative 1 because that vertex is on a solid line. This one is in a dotted, meaning it'll work for the parabola, but it will not work for the line. Okay, so I've got my solution set, which is right here, and there are infinite solutions in there. So our graph is our answer to these. Okay, solve by graphing. Okay, so if we look at this first one here, we've got a number over here, no numbers over here. So this is a circle. Okay, it is centered at 0, 0, because there's no parentheses. And my radius is actually the square root of this, which is the square root of 2. And the square root of 2 is about 1.4. Okay. So let's graph this circle. We're centered at 0, 0. We go out about 1.4. I guess we need to look, was it solid or dotted? It was dotted. Okay, so those should have been open circles, but we can just fix that with a dotted line around there. So that tells me I cannot choose those. So my ordered pairs are less than my radius. So I'm going to shade inside of that circle. And let's get rid of that dot because I cannot choose that. Again, I could pick 0, 0. If we pick 0, 0, that's 0 plus 0, 0, and 0 is less than 2. All right, this next one is just a simple parabola. It is the parent function of a parabola. So I've got a solid line, so we've got 0, 0, 1, 1 on that side, 1, 1 on that side, and 2, 4, 2, 4. Curve it up, and we'll curve that one up. And y is bigger than my parabola, so we're shading inside here. Okay, so that leaves my solutions to be, that's a dotted line, that's a solid parabola, and we're in there. So there are my solutions. Okay. Can I pick 0, 0? Sure, it's on that solid line. Can I pick this point right here? No, I cannot. Or could I pick this point right here? No, it's got to be, pick an obvious one. 0, 0 works. Maybe 0, 1's pretty obvious that it works. Okay. Did I skip one? No. Okay. Now, getting into a little bit harder. Remember, these can be any nonlinear equations. So reciprocal function, logarithm, exponential, circle, ellipse, hyperbola, parabola, quadratic, all of these. Okay. So solve by graphing. So let's take this one down here and figure out what that is. Well, this is the reciprocal function. And if you don't know what that is, I know you know what the radical does. So let's just pick some x and y values. Now we think about the domain here. What's the smallest thing that can go underneath this radical? Well, I know it can't be negatives, but it can be 0. And the square root of 0 is 0. Then let's move up. 1. Square root of 1 is 1. Now I'm going to skip up to 4 because I know 4 has a square root of 2. And 9 has a square root of 3. So we're looking at perfect square numbers. Okay, so 0, 0, 1, 1, 4, 2, and 9, 3. And it is a solid line. So we will connect those. And we want y to be bigger than that. Now, here's a little bit of a problem here is my graph stops here. I can't go this direction. So I cannot shade anything over here. So this x-axis or this y-axis kind of serves as a boundary line. I can't go past that. So when I shade, I can only shade in this first quadrant. So if I have my other equation landing over here, I'm probably going to have some imaginary solutions and no real solutions. So just make sure you don't just shade everything. Okay, so that's the bottom one. let's talk about this one. Okay, so I've got a 1 over here, so that tells me it's, you know, circle, ellipse, or hyperbola. I got squares plus, but I got numbers outside of my squares. So this is going to be an ellipse. Okay. And notice I've got parentheses, so that tells me that the new center is at 1, 0. Okay, there's no parentheses here, but this parenthesis tells me it moves in the x direction. Okay, and then this is over 1. So a in an ellipse goes with the bigger number, so it's a square root of 4. Square root of 4, which is 2. And b is 1. And let's see, a was on y and b was on x. So if I go to my center, and it's a dotted line, so we got a dotted line there. If I go to the center at 1, 0, okay, my a on the y, that means I'm going to go up 2, down 2 in the y direction. 1 on x, so that's 1 that way and 1 that way. And we are a dotted line. Okay. Now my ellipse is smaller than 1. Okay, this kind of serves as your perimeter here, or your boundary line, and you want your x, y values, your ordered pairs, to be less than that distance. So that tells me I'm going to shade inside here. Okay. Now it's kind of hard to see because I know my graph is really small, but I've got this curve here that's solid, and then it jumps up to your dotted line. So I can pick solutions inside of that. So 0, 0 doesn't work because it's on that dotted ellipse, but I believe 1, 1 would work, okay, or 1, 1.5, okay, something like that. Again, you can just plug them in and check them out and see if they work. The key is make sure you know what your parent functions look like and what your graphs look like, because that will be crucial on this quiz. Okay, so here are your suggested problems. This is the last section in Chapter 8 that we'll talk about. So start to be ready for your Chapter 8 test. Again, if you got questions, please let me know. And thanks for watching.